Okay, good morning. Welcome to the class. So today we will continue our discussion on Pigeonhole Principle, and we will talk about some more examples. So these are some tricky examples which is not that trivial that you are going to apply Pigeonhole Principle to solve it. So first of all, okay, so this is the first problem. So consider the numbers from 1, 2, 3, up to 100. Okay, so we have these 100 integers, and then what we are going to do is you ask anyone, you ask your friend maybe, to choose 51 numbers from them, 51 numbers. And then we want to show that no matter how these 51 numbers are selected, you can always find two of them such that one is divisible by the other. You understand the problem? So for instance, okay, so let's consider we choose the numbers from 50 to 100. So there are 51 numbers, right? So 50, 51, 52, up to 100. So there are 51 numbers. So among all these 51 numbers, so we have 50, 51, 52, and then 100. So among these 51 numbers, we can find two of them, let's say this one and this one, such that one is divisible by the other. Okay? So this is one kind of a selection of 51 numbers. Maybe you are thinking about another selection. So maybe this time, let's say we are selecting what? Let's say we are selecting all the 1, 3, 5, blah, 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 up to 99. And then let's say we are selecting also 50. Okay. Then in that case, this will be very easy. Then you can have a 3 here, and then you have a 99 here. Is that okay? So no matter how you are selecting, then you are always going to find one number divisible by the other. But then this 51 is a magic number. If we choose fewer, so let's say if we choose, let's say change it, let's say we choose 50, then we are not guaranteed to have this property. So if we are choosing 50 numbers, let's say these 50 numbers, 51 to 100, then no two can form a pair such that one is divisible by the other. Is that okay? Right? So if we are selecting 50 numbers only, then let's say we are selecting these 50 numbers, 51, 52, up to 100. Then you cannot find any two of them such that one is divisible by the other. But if we slightly increase this number, increase the selection from 50 to 51, then suddenly the story is very different. There must always be two numbers, one divisible by the other. Okay? So how can we prove this? So you may try to prove this by, for instance, we should not select the number 1. Because if we select the number 1, then when we select any other number, then we can find two numbers. Is that okay? Maybe you can start thinking of how to prove this. The obvious way seems to be we should use proof by contradiction, right? Yeah, because there are how many? There are too many ways of selecting 51 numbers. So if we need to argue them one by one, then it takes a long time. So it is much better if we try to argue this by proof by contradiction. Okay, so suppose that blah, blah, blah. Suppose that we can select 51 numbers and then no one can divide any other person. So in that case, one should not be selected. Okay, maybe you can also argue that probably one cannot be selected. Maybe you can argue that two should not be selected, and so on and so forth. But this takes a long time. So here, let me show you a very tricky way, okay, to prove this. So the hint here, so maybe we can think about this. Let's say the hint of proving this is we are using the Pigeonhole Principle. So the hint is to use Pigeonhole Principle to solve this. So in a sense, it's not the generalized one, it's the normal one. So the hint for you is that we are going to create 50 holes. So let's say there are altogether 50 holes. And then we are selecting 51 numbers. So it is like we are having 51 pigeons flying into these holes. And then to have a property that whenever a hole contains 2 pigeons, then one should be divisible by the other one. Is that okay? So whenever a hole has any 2 pigeons, so whenever 2 pigeons fly to the same hole, then we can immediately show that one of the number must divide the other number properly. Okay. Now in that sense, 51 pigeons into 50 holes, then there must be some hole with 2 or more pigeons. This is what we are going to do. Okay. Okay, this is the hint for you. And then let's design these holes together. Okay. So there must be a certain hole that contains 1. Am I correct? So let's put 1 here. Is that okay? So if you select the number, we are saying that there is a pigeon flying into this hole. Is that okay? And also there must be a hole that should put 2 to it. So we can find any one of the hole to put 2, but to make it greedy, let's put 2 also into the same hole here. Is that okay? So when 1 or 2 are selected, then there will be a pigeon flying into this hole. Is that okay? Okay, now 3. So we have a 3. Can 3 in this hole or not? Why? Why not? Someone says no. We should not put. So can I put 3 into this hole? If I put 3 into this hole, then it violates the property that we hope. 2 pigeons always, we will find one divide another. So if we put 3 here, what if 2 and 3 are flying here? Then you do not see 2 divide 3 or 3 divide 2. So, okay, so let's put 3 into some other new hole. Okay? So put 3 here, maybe. Is that okay? Now, 4. Where should we put 4? Can we put 4 here? Can we put 4 here? Yes, it can. Okay, interestingly, 4, you can put it here. The reason is that when 1 or 2 or 4 flies here, when there are any 2 numbers from 1 to 4 is selected, then one of them must be divisible by the other. If you choose 2, 4, then 2 divides 4. If you choose 1, 4, 1 divides 4. If you choose, what else? 1, 4, 1, 2, 1 divides 2. Is that okay? So you can put 4 here. How about 5? Can I put 5 here? No. Can I put 5 here? No. 5 here, okay. 6. Can I put 6 here? Okay, no, because we may be choosing 4 and 6. Can I put 6 here? Yes, good. We put 6 here. Is that okay? 7. Where should we put 7? Can I put 7 here? No. 7? No. 7? No. Yeah, we should put 7 here. Is that okay? 8. Where is 8? 8 here. Is that okay? Where is 9? Can I put 9 here? Can I put 9 here? Yes? No. We cannot put 9 here. The reason is that you have 6. 6 does not divide 9. So it's better to be safe. Put 9 here. Okay. Now, what can be put into the same hole? You can see. Okay, so this is a 1, 2, 4, 8. The next number that you should put here should be 16, and then the next number should be 32. Am I correct? And then you may put 64 here as well. This one is 3, 6. What is the next number? 12. Very good. And then the next number will be 24. Excellent. Okay. And this one is 5 and then 10. The next one, 20. Is that okay? Okay, this is a very interesting way. Okay, so we can call this bucket of 1 a hole of 1. This is a hole of 3. This is a hole of 5. And this is the hole of 7. This is the hole of 9. And then the last one is the hole of 99. So inside the hole of 1, we put all the numbers, which is 1 times the 2 power. Is that okay? So 1, 2, 4, 8, 16, 32, 64. In the hole for 3, we are putting 3 times the 2 power. Okay, so it is 3, 6, 12, 24, what else? 48, 96. Is that okay? and so on and so forth. So how about the bucket or the hole? So sometimes I call it a bucket. So it is like a bucket. So it's like a bucket. Yeah, a bucket. Okay. In the hole for 99, okay, there is just one number, 99. Okay, but we don't care. Okay, we just put 99 here. Now, what is so special about this? The special thing, as we have mentioned before, is that when there are two numbers falling into the same hole, then these two numbers must have one dividing the other properly. Is that okay? So if you count it, so 1, 3, 5, 7, 9, up to 99, there are exactly 50 different kinds of numbers. There are exactly 50 different kinds of holes that you are going to have. And when you are selecting 51 numbers, no matter how you put the numbers, there must be some hole containing 2 or more numbers. Okay, is that okay? So let's say when I'm selecting what? When I'm selecting this set, 50, 51, up to 100, so there are 51 numbers. So what will happen? So in the hole of 1, then you will have 64 flying inside. In the hole of 3, then you will have, so this is the hole of 1, then you find 64 flying inside. In the hole of 3, then you will find 96 flying inside. Is that okay? In the hole of 5, what else? In the hole of 5, you will see something like 80. Is it? 80 flying inside. Is that okay? In the hole of 7, do we see anything? In the hole of 7, we will see, what? 56 maybe. Is that okay? 56, right? In the hole of 9, we will see what? In the hole of 9, we will see what? 9. Yeah, I'm not that good at mathematics. 72, right? Very good, 72. Is that okay? And blah, blah, blah. So some hole, you will just have one number flying into it, because 64 belongs to hole 1. 96 is equal to what? 96 is equal to 3 times 2 to the power 4. 5. Okay? Is that okay? So it is in the hole of 3. But in this case, when you look at the hole for 25, you will see that 50 is selected, and also 100 is selected. Okay? So these two numbers, they are flying into the same hole of 25. And then whenever there is one hole containing 2 or more pigeons, then you will see that the two numbers there, one must divide the other. So that's it. This is the proof. Is that okay? So no matter how you select 51 numbers, then there must be two numbers, one dividing the other. If you are okay with this so far, could you please raise your hand? Okay, excellent. So this is a very tight result, as mentioned. If we choose 50 numbers, there is no guarantee. Yeah, we can find a very special case of 50 numbers such that no one divide another one. But on the other hand, if we just change from 50 to 51, then suddenly it is always guaranteed. Okay, so this is a very tight result. Okay, so this is the first example. Okay, let me show another example. So let me wipe this board. Okay, another example is also a very tight result. Okay. Okay, so first of all, let us write down a sequence of numbers. Let's say whatever. Let's say 1, 5, 2, 3, 8. So let's write down the numbers from 1 to 10. Okay. In some random way. 1, 5, 2, 3, 6. Maybe 6 is here. Maybe I put a 7 here. Maybe I put a 10 here. Maybe I put a 9 here. And then maybe I put a 4 here. Is that okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 numbers. So we call this a sequence. Okay, so we read this from left to right. So this is a sequence. So this is a sequence of numbers. Now, given a sequence of numbers, we can talk about what is a subsequence of numbers. So I'm going to define some terms. So what is a subsequence? Subsequence is you may be selecting only part of the numbers. Maybe I'm selecting this one, this one, this one, this one, and this one. This is called a subsequence of. So from this one, if I select just 7, 5, 2, 3, 10, then I will get 7, 5, 2, 3, 10. This is a shorter sequence. Is that okay? But then the ordering of the numbers is the same as the ordering of these numbers in the original sequence. That's why we call it a subsequence. Is that okay? Okay? So subsequence means that we can skip some of the numbers, drop it away, and then take the remaining. Okay? Is that okay? Okay, so subsequence, we can also talk about, so now subsequence, I can define subsequence into two different forms, two different kind of special subsequence. One is called increasing subsequence. And the other one is called decreasing. A subsequence is increasing if after you take the numbers there, the numbers form is one the smaller, larger, 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 and then the largest. Is that okay? So this is not an increasing subsequence, and it is not a decreasing subsequence. But on the other hand, let's pick this number 2, 3, 6, and 10. Okay, if we select the numbers 2, 3, 6, and 10, 2, 3, 6, 10, then this is a increasing subsequence. Is that okay? Is that okay? And then we can also talk about decreasing subsequence. For instance, I can have 10, 9, 4. And then this is a subsequence of the original sequence. Yeah, it is also a contiguous, consecutive in order, contiguous subsequence in the original sequence, and then it is decreasing. Is that okay? Is that okay? So we can have sequence that is increasing, we can have sequence that is decreasing, and then we have sequence that is neither increasing nor decreasing. Is that okay? Good. So we are clear about this definition of subsequence, right? And also increasing subsequence and decreasing subsequence. Now, this theorem says, okay, if I have 10 numbers, 1, 2, 3, up to 10, if you arrange it in any order, you can always find either an increasing subsequence or a decreasing subsequence, or both that has length more than 4, more than or equal to 4. So we can find an increasing subsequence or a decreasing subsequence with more than or equal to 4 numbers in the subsequence. So if we look at it, so here, this is the example. So in this subsequence, you have 2, 3, 6, 10. Is that okay? So this is an increasing subsequence of length 4. The length is 4. There are 4 numbers inside. Okay? I'm not saying that you can always find an increasing subsequence and decreasing subsequence at the same time. But I'm saying that you either find this or both. And then they are of length long enough. Okay, 10 is a magic number to guarantee a length 4. If you have 9, then you don't. I'm going to show you. This is very easily constructed. So if we have 9 numbers, then what will happen? So let's write down the 9 numbers like 7, 8, 9, 4, 5, 6, 1, 2, 3. Is that okay? So you have 9 numbers, let's say in this particular order. If we look at it, I'm writing this in a batch. 7, 8, 9, increasing, right? And then 4, 5, 6, also increasing. And then 1, 2, 3, increasing. Is that okay? And then it is easy, very easy to see that you cannot find an increasing subsequence of length 4. There is no increasing subsequence of length 4. If you select 7, 8, 9, then all the numbers here are less than 7, 8, 9. So you cannot make it longer. Okay? You cannot make it longer. You cannot have 4, 5, 6 and then make it longer. And then at the end you have 1, 2, 3, you cannot make it longer. Is that okay? On the other hand, if you are selecting numbers from one number from this group and one number from this group, then it has to be decreasing, not an increasing sequence. Is that okay? And then what you can do is that you can at most select 3 numbers here to form a decreasing subsequence. So the longest decreasing subsequence in this example is also 3. You cannot have 4. Is that okay? But on the other hand, if you have 10 numbers, no matter how you arrange it, there must be a length 4 increasing, or there must be a length 4 decreasing. Okay, so let's rearrange it a little bit again. Yeah, you have 2, 3, 6, 10, am I correct? So let's make it disappear so that you don't have this one. Yeah, so let's try to avoid this length 4. So let's change 2, 3 into 3, 2. Okay, let's do this a little bit, 3 and 2. Then you don't have 2, 3, 6, 10, because now 2 and 3 are not in the same order. But still, we can have 1, 2, 6, 10, am I correct? Yeah, so we don't like it, 1, 2, 6, 10. So let's change it to what? Yeah, let's change it more, let's make it 3, 2, 1. 3, 2, 1. Okay, so you don't have 3, 2, you don't have 1, 3, 6, 10. You don't have 1, 2, 6, 10. You don't have 1, 3, 6, 10. So what will happen? Oh, but then you will have what? 7, 3, 2, 1. Am I correct? This time it is a decreasing subsequence of length 4. Okay, so let's change it a little bit to see if we can. Let's change it to 3, 7, 5, 2, 1. Okay, is that done? Well, this time you have 3, 5, 6, 10. Suddenly, you change 3 to some early position. You will now have 3, 5, 6, 10, right? So what should I do? Let's change it to what? 5, 3, 7. Okay, is that okay? Can you still find any increasing subsequence? Any increasing subsequence of length 10 and length 4? Yeah, there is. Okay, I can see one. There is 5, 7, 8, 10, right? Yeah. So, okay, change it. Change the 10 and 8. So let's make it 10 here and then 8 here. So do we still have increasing subsequence of length 4? Increasing.
1, 6, 8, 9.
Oh, very good. 1, 6, 8, 9. So what should I do? Let's change the 6 and 9. Okay, let's try to change this 6 and 9. Okay. 6 is here, 9 is here. Do we still have increasing? Yeah, there is no increasing, right? Do we?
3, 7.
3, 7, what?
1,
No, 3, 7, no, okay. So there is no increasing. Do we still have increasing? Yeah, we don't have increasing anymore. But now we have decreasing. That's a very long decreasing. 10, 9, 8, 6, 4, right? Okay. Yeah, let's change 4 and 8. And then what will happen? Yeah, it's still useless. We still have, now we change it. There's no decreasing, it seems like, but there's now an increasing. So you have 1, 4, 6, 8. Or you have a 2, 4, 6, 8. Okay, anyway, what I want to show is that no matter how you change it, there must be 4. There must be at least, you can find an increasing or some decreasing of length 4 or longer. Okay, how do we prove? Now, this is very, very difficult. Yes, very, very, in general, let me tell you the general result. If the sequence, so here it is 10, if the sequence is of length n squared plus 1, then it implies you can find an increasing subsequence of length n plus 1, or you can find a decreasing subsequence of length n plus 1. Okay, so n squared plus 1 in any order implies an increasing n plus 1 or a decreasing n plus 1. Is that okay? Okay, now how do we show? Let's see. Now I'm saying that this proof, this is a difficult problem. Why? We are going to use two techniques together. First of all, we are going to prove it by contradiction. And the other one is we are going to use Pigeonhole Principle to help us to get the contradiction. Is that okay? So Pigeonhole Principle is one of the theorems that is proven by contradiction. So we are using a contradiction proof that has some part inside that requires another contradiction proof. So this is quite complicated. Is that okay? So we prove this by contradiction. And we use pigeonhole principle to help us to get the contradiction. Okay, so this is the strategy. Okay.